Assalamu alaikum dears, myself SLK. In this short tutorial, SLK students present the earthwork calculation using mean depth method, or you can say the cut and fill calculation by mean depth method. Remember, previously we have already learned the calculation of earthwork using mean area method. If you have not watched that video yet, just click the link below in the description. In this method, the first thing I want to explain is just the concept of mean depth method. The mean depth method calculation can be done in the given table. Remember, this table represents the column of RDs, natural surface level, formation level, depths, mean depths. That's why this table is known by mean depth table. And then different areas, the summation of areas, then the interval or length, and then the quantities in form of cut or fill. For better understanding, we'll just give solution to a problem as we always do. Let's say this is example 1. In this example, we have a portion of a road and we are asked to work out the quantities of earthwork for this portion of road. The formation width of the road is 10 meter. The side slope are also given, like in cutting we have 1 and 1, and in filling we have 1 and 2. The natural surface level and the formation level at different stations are given as below. Let's say stations 0, 30, 60, 90, 120 and 150. So the road portion is from 0 meter to 150 meter. And these are NSL or natural surface level. And the formation level are also given like these guys. And the section in cutting and in filling are also given like this one. This section is cutting and this one represents the section at filling. Now I'll start the solution. Remember, for the solution I'll use the given table, this one. The table which was just introduced a few seconds ago. Here again I'll just draw this section just to make the calculation easy. Like the section in cutting and the section in filling. And I'll fill some columns with the known values like the RDs are given from 0, 30, 60 to 150. And the NSL are also given like these guys. The FRL are also given. Just don't worry about this blank row, okay? Now from here, the calculation will start. The first thing I need is just the depth at each RD, right? So the depth can be taken if we just subtract NSL from FRL. So 1 pipe 2.0 minus 2 pipe 1.0 equals 1. And again, 2 pipe 1.8 minus 250.9 equals 0.90. And so on. 2 pipe 1.6 minus 2 pipe 0.9 equals 0.7. And this one. And here this one, 2 pipe 0.8 minus 2 pipe 1.2 equals minus 0.4. This means here at this section we have cutting. And the above station are just in filling. Alright. And again this one, 2 pipe 0.6 minus 2 pipe 1.4 is just minus 0.8. So these two stations just contain the cutting. And now I'll calculate just the mean depths. MD just represent the mean depths, okay? So we'll just add two depths and we'll divide it by 2. Like these two guys. 1 plus 0.9 divided by 2 is just 0.95. And these two guys, like we'll just do this, the summation of two depths are just the depths of two stations divided by 2, right? Like 0.9 plus 0.7 divided by 2, this is 0.8, and 0.7 plus 0.6 divided by 2, this is 0.65. And the next thing, here is a nice technical term called intermediate point. What's intermediate point, right? Look at the station, 90 meter and 120 meter. From the 90 and 120 station, you can just say we are just changing from filling to cutting, right? Because the minus just represent the cutting. So there is just a point known by intermediate point. Let's consider this guy as the profile of a road, right? And just consider me or imagine me as a designer, okay? And here I'm just placing a formation level over here like this one. This green line just represents the formation level, okay? Now you can clearly see this portion is just in palm up cutting, and this one is in peeling, again cutting, peeling, cutting, peeling, and again cutting, right? So if you see, this is cutting and this one peeling. From cutting, we are just going to peeling, which means the sign is changing. We're here, we're there, and there, right? So you can clearly see when we are going from peeling to cutting or from cutting to peeling, there is a point having no cutting and peeling, right? Having no depth though. So this point is known by intermediate point. This point does not have cutting and peeling because the depth is zero, right? Over there. Alright, now where is the given point? I mean, where is just the intermediate point? Okay, you can clearly see this one, the 8 station, or as you can say 8 meter. This is just right about the 8 meter. But what is the length of this guy from zero, right? So let's calculate this one over here. Let's say the distance of IMP, which means intermediate point. There is a nice plugin chugging formula, but I'll do just plugin chugging, okay? Like this will be just, of course, the depth its last station in filling, like the depth at 90 station, right? Which is 0.6 divided by the same depth plus the next one depth, like 0.4, right? Or just the depth at the next station times the interval, which is of course 30, like 0, 30, 60, which represent the interval is just 30 meter, okay? Plus the last station, which is 90. This is the last station, okay? So we'll get, of course, 108 meter. Right, this is just the length of intermediate point, okay? Or just the distance of intermediate point. So I'll put this value over here, right? And the blank row was not just useless. I left this guy for this time, okay? Right? So 108. We just got another station, okay? Depth will be 0. Now the mean depth will be just, of course, 0.6 plus 0 divided by 2 equals 0.3. And again 0 plus 0.4 divided by 2, this is of course just 0.2 but minus 0.2, right? Because this station have cutting in there, right? And again 0.4 plus 0.8 divided by 2, this is of course 0.6, also minus, okay? Now the next thing, we can calculate the central area, or just BD. The BD or central area just represent this red portion, okay? Just look at this red portion. This is just the central area, or BD. Like you can say 10 times 0.95, this is of course 9.5. And again 10 times 0.8, this is of course 8. And 10 times 0.6, this is 6.5. Again 10 times 0.3, this is 3. And again 10 times 0.2, this is minus 2 and minus 6. Now it's the turn of SD square. SD square is just the area of sides, but the area of both sides, okay? Because the slope is just uniform to both sides, okay, in this section. If the slope were not uniform, then you can use, of course, SD square divided by 2 per one side and SD square divided by 2 per another side, okay? For this time, the slope is just uniform, so we'll use only SD square. Like you can say d square, or you can say 0.95 square. The d means the mean depth, okay? Like 0.95 square times the slope. The slope is just 2 because it's 2:1. So 0.95 square times 2, this is of course 1.8. And again 0.8 square times the slope, this is of course 1.28, and so on, right? But after this, there comes cutting. So 0.2 square times the slope of cutting, right? Not the slope of peeling, okay? So we'll take only 1 because 1 divided by 1 is just 1, okay? So 0.2 square times 1, this is of course 0.04. And again 0.6 square times the slope in cutting, right? Just 1. So we can get, of course, 0.36. So we got BD in SD square. Now we can get the summation of all these two areas, like just 9.5 plus 1.8, this is of course 11.3, and 8 plus 1.28, this is of course 9.28, and so on. Just add all these two guys and plug this in a column of summation of area, right? After this, we'll do just plug in check in per interval length. Okay, the interval at the station is just 30 meter, and 30 meter over here, and 90, and of course 108. There's difference of 18, so 18 meter, and this is just 120 minus 108, so 12 meter, right? This is just the length between two RDs, are just the between two stations. Okay, no problem. Just find the distance between two stations. Like let's talk about this one, 30 and 60. What's the distance between these two stations? Of course, just 30 meter. Okay, and look at this one, 120 and 150. This is again just 30 meter. And let's talk about this one, 90 and 108. What's the difference between these two guys? What's the distance between these two stations? Of course, just 18, right? Now we can calculate the cut and fill, which is known by quantity. Remember, the quantity means just the volume over here. And the volume is always the cross-sectional area times the length, right? So the summation of area times the interval or length will be just cut or fill. And the cut or fill will be just in form of cubic meter, right? Like 11.3 times 30, this is of course 339 cubic meter fill, because the values are just positive. So this is just fill, okay? And again, 9.28 times 30, this is of course 278.4. And the next one is of course just also filling, and the next one is also filling, but the next one is just cutting, like 2.04 times 12, this is cutting of course, and the next one is also cutting because the depth and the area is just in negative form, right? So we got cutting and filling in a nice way, and that way is just of course the mean depth method. And now if you want what's the total filling or what's the total cutting, okay, just add all these four guys, you'll get the total filling, and add these two guys, you'll get the total cutting, right? So this is done, right? We learned about the mean depth method, and we learned how to calculate cut and fill using mean depth method, right? Thank you dears for watching. See you next time. Salam.